Okay, we will continue in part 3 of chapter 3. Okay. Okay, remember sidebands. Now we will discuss about sidebands. Sidebands in frequency modulation. So remember in your chapter 2 about sideband in amplitude modulation, where you have normally sideband, we will discussing about frequency domain. So you have your signal, the carrier, and sidebands. Okay, so this is FC. This is FC plus FM. This is FC plus FC minus. Sorry, FC minus FM. So this is, we call it carrier. This is upper sideband. This is lower sideband. Okay, for AM. But in FM, we will have many significant upper sideband and also more than one significant lower sidebands. Okay, so it is a product of any modulation, either AM, FM, or PM. But PM we're not discussing lah. Okay, so now we are discussing about FM. So it is also a product of FM modulation sidebands. Angle modulation produce more bandwidth compared to amplitude modulation. Bandwidth of an FM signal is usually much wider compared to that AM signal with the same modulating signal. Infinite number of pairs of upper and lower sideband generated. This is the different feature of angle modulation compared to amplitude modulation. Amplitude. Sorry, I typo sikit. More sidebands means more immune to noise. Kat sini dia punya bagus sideband. More sideband means more immune to noise. Sidebands and modulation index. FM produces pairs of sideband. So biasalah sideband ada dua kan, atas dan bawah, pair. Sebab dia minus FM dengan FC minus FM dan FC plus FM. Still remember the equation just now? FC plus FM, FC plus 2 plus minus plus minus 2 FM, FC plus minus 3 FM. Kita ada plus minus ni. So this is first sideband, second sideband, third sideband. FC plus minus 4 FM, etc. hingga FC plus minus N FM. N is the significant, the number of significant sideband. FM produces pair of sidebands based from the carrier in multiples of the modulating frequency. Yani multiples of modulating, multiples, multiply 1, multiply 2, multiply 3, multiply 4, multiply, etc., etc., multiply n. The number of significant pairs of sideband determined by the number of the value of modulation index. So the modulation index, this value, this equation yang you dah kira tadi, yang kita dah kira tu, this value of FM determine the number of significant pair of sideband. Apa ni? Number of significant pair of sideband ni, FC plus N. N ni number of significant FM. The modulation index M in the FM signal is ratio of the frequency deviation, yang ni kita dah tahu, can also be written as FD, ini lah delta F, to the modulating frequency. Kita tengok ni kan, kita tengok dah example tadi. Okay, significant sideband. Okay, you can see from here. So example 1, this signal have, this is the FC. So FC minus FM, FC plus FM. So this is FC plus minus, FC plus minus FM. So this is 2, this and this one. The second sideband is FC plus minus 2 FM. Ini 2 FM, ini FM. 1 FM, 2 FM plus. FC plus FM, FC minus 2 FM. FC plus 2 FM, FC minus 2 FM. Ini represent yang ni. Okay. And third is FC plus minus 3 FM, which is this one, and this one. Okay. This is 3 FM. The bandwidth is 3 FM. We call it. So bandwidth of significant spectrum equal to 6 FM. So we have the FC here. FC here. So this is 1. This is 2, 3, 4, 5, 6, 7, 8. FC plus 8 FM. Okay, sini sama. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay, so yang ni 3 FM. Significant bandwidth is 6 because 3 plus 3. Yang ni bandwidth significant spectrum ataupun kita panggil the spectrum bandwidth. The spectrum bandwidth is 16 FM. 8 plus dan 8 minus. Okay, so yang ni 3 FM plus 3 FM minus. So the total bandwidth of this spectrum is 6 FM. Okay, boleh ya? Okay, FM equation. Ini tricky sikit lah. Okay, matematik sikit. For FM equation, when a modulating signal is a single sine wave, the FM equation is FM equal to time domain VC cos omega CT plus M sin omega MT, or VFMT equal to VC sin omega CT plus M sin omega MT. Beza ke? Sini ya. Ini sin, ini cos. Sama je. Sin. Okay. To expand the equation into complete FM equation, including its sidebands, is very difficult. Thus, Bessel function is used to solve the equation. So, dalam case FM signal, kita gunakan Bessel function. So, what is Bessel function? Okay, because it involves trigonal. See, FM cos of sine. Cos A plus B equal to cos A cos B minus sin A sin B. Therefore, FM VC cos omega CT cos M sin omega MT minus VC sin omega CT sin M sin omega T. Kepanjang tu. Where cos and sin is a trigonal series called the Bessel function. So solving this equation need to solve using trigonal identity. Ni cosine of sine. Cosine of sine, this one. Cosine of sine. Cos A plus B. Ini kena study dulu. Okay. So expanding using Fourier series akan menghasilkan cosine M sin omega mt equal to J naught M plus 2Jn M cosine n omega mt for n even. N nombor ganjil, nombor genap. And sin M sin omega mt equal to sigma 2J M sin n omega mt for n hot. Apa beza dia? So ni ada 2 pi Jn, sama kan? 2 pi Jm sin. Ini sin, ini cos. So dia ada J ni, Jn. Okay. Substitute in VFM. Kembangkan lagi. Selesaikan this equation. Okay. You kena tengok equation ni. Tak payah hafal, tengok belakang. Using Bessel identity, J minus Nm equal to minus J minus 1 to the power of N J Nm. Okay, J Nm equal to J minus N and minus J minus N. Okay. Hence, FM equation also known as WBFM, wideband frequency modulation. Okay, so this is the simplified equation. You have expand the equation yield. Expanding this equation menghasilkan this equation, where this is the carrier and the rest is the sideband. See, you can see you can compare this equation. You have the positive, the carrier. You have the carrier, which is positive, and ECJ, which is J1, J2, J3, J4, and till Jn. And we have the positive part, or the omega C plus omega M, omega C plus omega M part, which is the higher frequency or the right sideband. And we have it pair, which is cos omega C minus omega M, which is represent the lower sideband. This is called sideband 1, a pair of sideband 1 at frequency, this frequency, and this frequency. We have sideband 2, pair of sideband 2, pair of sideband 3, pair of sideband 4, up until pair of sideband 6. Okay, so you tengok dia punya equation frequency ni, omega C plus omega M, ataupun kita kata tadi FC plus FM. Sama lah, omega equal to 2 pi F kan. So this is omega C plus 2 omega M, ataupun FC plus 2 FM. Dia ada yang negatif dia, pair dia, and so on and so forth. Okay, so using this from this equation, we can solve using Bessel function, where M is modulation index. Okay, you still remember modulation index tadi. Vc is the peak amplitude of the unmodulated carrier, basically the amplitude of the carrier. J naught M equal to carrier component J1, first set of side frequency displaced from the carrier by omega M, meaning this is the carrier FC. So this is the plus omega N or the plus FM. This is the minus FM. This is plus FM. This is, we call it first pair of first sideband. J2 is the second pair of second sideband, which is the carrier displaced by 2 omega m. Maknanya dia selang 2 omega m, 2 FM. And until Jn, which is the n set of side frequency displaced from the carrier by n omega m. So maksud dia, kalau kita ada frekuensi domain, ini ialah Fc ataupun omega c sama. So displaced by n. So let's say n ialah 4. So 1, 3, 4. Yang ni ialah n. Jn. Sama belah ni. 1, 2, 3, 4. So, untuk kalau n equal to 4. So n set of side frequency nombor 4 displaced from the carrier by n. Displaced daripada carrier ni banyak 4. 1, 2, 3, 4. So berapa banyak dia punya sideband ni bergantung kepada nilai modulation index. Modulation index ni kita akan tengok dia punya nilai M pada table Bessel function table. Okay. So this is the table where the modulation index is in the left, and on the right it has the value for J. Okay, J for the first, second, third, fourth, fifth, sixth till n. This is the n of Bessel function. Okay, the value of modulation index will determine how many significant sideband you have for that signal. For example, if n equal to 1, it will only have 3 significant sideband. 1, 2, and 3. 4 until 4 and onward, there is no significant, meanings the value is 0. Okay, if you have modulation index like 5, you have many sidebands. N equal to 8. Okay, 8. N equal to 8. So the bandwidth is bigger, much more bigger. Okay, so from this you can determine the value of sidebands from this table, or you can determine from this this graph. Okay, it is the same. Let's see one example. You have, this is 1. You have the carrier amplitude for the carrier is 0.77. Okay, 0.77. Okay, here modulation index, here 1. You have here, you go up here, this is here, right? This is 0.77 for J0. See, this is J0. See, apa tu J1? J1 is 0.44. Okay, you can see from here, this is J1, this line. So it meet here 0.44 for J1. J2 0.11. Okay, so where is 0.11? This one. This is J2 line. This one, this line. So here is 0.11. Yeah. Okay, so that's all. So you can read the example. Okay, so can read one example yourself for m equal to 1, where you should have 0.77. See here, right? 0.77, 0.44, and 0. 1, 1. I have shown just now. For m equal to 2, m equal to 2 here, we have 4 significant sideband, 1, 2, 3, 4. Okay, what is the value here? 0.22, 0.58, 0.35, 0.13, and 0.03. Okay. Okay, so that's all. That's all. We will continue in later video. We will discuss about power in FM signal. So that's all for this part, the sideband. Hopefully you can read or you can watch later again, or you can study a little bit on Bessel function and this Bessel table. You should be able to understand how to derive the value for sidebands, the peak of the sideband if you are given the modulation index, or you can, or after you calculate the modulation index, you get the value, you can derive the value of sidebands from the table. So that's all. Until then that's all. We'll meet again after this, the next video. Okay, bye bye.